Hello friends, welcome to Electronic Circuit Hub. So today we are going to learn about the input and output characteristic of BJT, bipolar junction transistor. Okay, so I will draw the schematic and I will show you the input characteristic of BJP. I will show you the output characteristic of BJP in the LTSpice, right? So if I say the input characteristic of BJT, that means the plot between VBE and IB, that means the plot between voltage across base to emitter junction and the base current. If I say the output characteristic, that means the plot between VCE and IC, that means collector to emitter voltage versus collector current. So let us draw the schematic first. So I will teach you how to draw the schematic in LTSpice. So go at this component. This is the component. So you need one NPN transistor. So this is the NPN transistor. Then you need two resistor. You go here. This is the two resistor. Control R to rotate the component. So you have rotated the component by using control R. You can see this is control R, right? Then you have to look for voltage source. So this is the voltage source, right? And this is the voltage source for input and output. Now you have to take the wire, do the wiring. So connect it. So it is being connected, right? So you can use the wire to connect it. So let me further move this voltage source right here somewhere. All right, yeah, 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 yeah. And this is the value of this register is 4.7k. The value of this resistance is 470. Right. You may edit this. So this is, let's say, net base to emitter voltage, and this is VCE base to collector voltage, right? If you want to move any component, you can use this button, that is MOV written here. So take it here. You can connect anywhere MOV. This is VB, right? And this is, let's say, VCE. Okay. So now you have drawn your schematic. You can see it is clearly drawn here. Now what you will do to see the input characteristic of BJT and to see the output characteristic of the BJT. To see the input characteristic of BJT and to see the output characteristic of BJT. So you have to assign this part Q1. So right click it here, pick the new transistor. You can use one NPN transistor like BC846B, right? So I will show you now in simulation. So go at simulate, edit simulation command. You are going to do it here, DC sweep. Always remember, if you want to check the input or output characteristic of any device, you have to do the DC sweep, right? So let's say your first source is VB. So you have written VB. Sweep type is linear and your voltage vary from 0 volt to 3.3 volt, right? And let's say your increment is 0.05. Your second source is here. You can see your first source is, right, your first source is VB and your second source is VCE. So here you can write VCE linear, start value 0 volt and stop value 12 volt and increment, let's say, 0.1 volt. So basically here you are assigning your source for different value. Let's say what happens at output when your that collector voltage is 0 volt and it goes up to 12 volt. When this voltage is 0 volt, when this is voltage is 12 volt with increment of 0.1 volt, right? So likewise for input characteristic, what will happen if your input source is 0 volt and it goes to 3.3 volt? So you have to click it OK. Now you have done here. I forgot to add the ground here, right? Now everything is looking so good for me, right? Everything is looking so good for me. Now I will run the simulation. So go at this button, run the simulation, right? And go at window, tile window vertically, just zoom it for proper clearance, right? Now I will show you the, yeah. So this is the VBE versus IB plot. Your VBE in x-axis and your IB in y-axis. So you can see you have different voltages for base to emitter, and accordingly you can see your current is varying. Accordingly you can see your current is varying. So I already told you the input characteristics is the plot between your VBE and IB, and output characteristics is your plot between VCE and IC. So this is the plot between, this is VBE, which is varies from 0 to 3.3 volt, and this is the current, base current, right? And you can see here in the somewhere at 0.6 your transistor turns on, then the current start flowing. Now I will do a small modification. Go ahead, simulate, edit simulation command, and I will show you the plot between VCE to IC. So you have to change your first source. So earlier it was VBE, so you kept it VCE, and it goes from 0 to 12 volt with increment of zero point 0.1. Then you change this source. This is VBE and linear, it goes 0 to 3 volt, 0 to 3.3 volt with the increment of 0.05. So at a time you have to vary one source and you have to fix other source. Like when we were doing the input characteristic analysis, we varied input source and the output source was fixed. Now here in the first source, your output source is vary and your input source is fixed. Now it's okay. Run the simulation again. So you have to click it here. You have run the simulation again. Now I will show you the plot between, yep, it's look quite good. The plot between, this is the plot between VCE and IC, right? So you can see your collector voltage is varying from 0 volt to 12 volt, and this is your collector current. In the x-axis VCE, in the y-axis the IC. So this is your current 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is the output characteristic, and this plot shows that the output characteristic of your BJP. So hope you understand about the input characteristic of bipolar junction transistor and the output characteristic of